Welcome to the .NET Way. This is episode 5 of our .NET Core interview series, and today we're diving into one of the most important concepts in modern development, dependency injection, also known as DI. Aarohi is here to walk us through the fundamentals, real-world usage, and best practices around DI in .NET Core. Let's jump in. Aarohi, for starters, what exactly is dependency injection?
Dependency injection is a design pattern that allows objects to receive their dependencies from an external source rather than creating them directly. In .NET Core, DI is built in and helps promote loose coupling, testability, and maintainable code.
How does .NET Core implement DI by default?
In .NET Core, DI is configured in the configure services method of startup.cs or directly in program.cs for .NET 6+. We register dependencies using methods like AddSingleton, AddScoped, or AddTransient, and they are injected into constructors automatically by the framework.
Can you quickly break down the lifetimes?
Sure. AddSingleton, one instance for the entire application lifetime. AddScoped, one instance per HTTP request. AddTransient, a new instance every time it's requested. Choosing the right one depends on the service's responsibility and state handling.
How does this work in real code?
Let's say we have an interface called IEmail along with its implementation, email service. To register it in the dependency injection container, we use services.AddScoped, angled brackets, IEmail service, email service, and close the brackets. Now, in our controller, for example, account controller, we inject this service through the constructor. Here's how it looks. Public class account controller, controller, open brace, private read-only, IEmail service _ email service, Then, the constructor. Public account controller with IEmail service, email service as the parameter, open brace, _ email service equals email service, close brace, close class. This way, the email service instance is automatically provided whenever the controller is created, scoped per HTTP request.
Why is DI such a big deal?
It makes the code loosely coupled and easier to test with mocks. It also adheres to solid principles, especially the dependency inversion principle. Plus, it centralizes service management, which simplifies configuration and maintenance.
Why is DI such a big deal?
It makes the code loosely coupled and easier to test with mocks. It also adheres to solid principles, especially the dependency inversion principle. Plus, it centralizes service management, which simplifies configuration and maintenance.
What if one service needs another?
Yes, services can depend on other services. The DI container resolves the entire chain. Just inject dependencies into constructors of services like you do in controllers.
What if I have two implementations of the same interface?
You can use name services, key-based factories, or IID injection. In some cases, injecting a factory or using activator utilities allows runtime resolution of specific implementations.
What about static helper classes?
No, static classes can't be injected because they don't have an instance. But it's better to avoid static utility classes in DI-based design. Instead, create injectable services with a singleton lifetime if needed globally.
Isn't using ISelector.GetService the same thing?
That's called the service locator pattern, and it's considered an anti-pattern in most cases. Constructor injection is preferred because it makes dependencies explicit and promotes better design and testability.
Any anti-patterns or mistakes you've seen?
Yes. Registering services with the wrong lifetime is common. For example, using AddSingleton for a service that holds per-request data can cause bugs. Also, resolving scoped services in singleton constructors will throw errors unless done carefully using factories.
Thank you, Aarohi. That was a solid explanation of dependency injection in .NET Core with real use cases and best practices. If you learned something today, be sure to like, comment, and subscribe to the .NET Way. In episode 6, we'll challenge Aarohi to design a custom middleware and explain how middleware works behind the scenes. See you in the next episode.